This video is about a systematic attempt to measure air traffic levels and count persistent jet trails or chemtrails using a Raspberry Pi computer-based network. This report is dated April and May 2014. This research used a collection of software and hardware to receive and decode ADS-B messages from aircraft, as well as photograph the sky at 1-minute intervals. The software ran on several Raspberry Pi computers stationed at up to 6 different locations in the United Kingdom. The objective was to count the number of aircraft detected at a given location and compare these counts both on an hourly and daily basis when the skies were clear enough to have seen persistent jet trails or chemtrails. Time-stamped, time-lapse videos were generated for images taken between sunrise and sunset each day. These were inspected to count the number of trails observed in each 30-minute period of daylight. Trail counts and aircraft counts were collated into a Microsoft Access database. SQL queries were then developed to allow comparison of aircraft counts during periods when trails were observed and clear periods when no trails were observed. I'd like to start with an overview of the persistent jet trail or chemtrail phenomenon. Since the mid to late 1990s, people around the world have observed what have become known correctly or incorrectly as chemtrails. Mainstream science and commentary mostly considers these trails to be a normal result of everyday air traffic movements, i.e. they are purely and simply condensation trails formed as a result of burning kerosene. Others maintain they are part of a secret clandestine spraying program which is suggested to be either for geoengineering in the form of some kind of solar radiation management (SRM), introducing toxins into the atmosphere to affect or control human health, introducing toxins into the atmosphere to affect or control agriculture. I have previously compiled 2 reports about these trails and their possible nature. The reports are posted on my website, which is checktheevidence.com, or you can contact me using the details in these videos if you can't find these reports. These reports were posted in 2007 and 2010. I'd like to consider the days when we see trails and the days when we don't see any trails. One of the main unanswered questions is why we observe days when no trails appear, not even ones that persist long enough to actually see them. And then on other days we can observe many trails for such a length of time that they can even seem to spread out and form a haze blanket. There seems to be no satisfactory explanation for these different scenarios beyond either hand-waving or making claims which are not really supported by the evidence. For example, if it is caused by the state of the jet stream and its influence on the stratosphere, there has been no clear explanation as to exactly what sort of circumstances or conditions would cause trails to persist for many minutes, and specifically how the jet stream changes would cause these conditions to change. Another of the curious things that people have observed and photographed are grids and circles of trails. In the photographs here, mainly from around the United Kingdom, a number of circles and grids of trails that can be seen. There seems to be no good, clear explanation for this, and to my knowledge, military exercises have not been proven to be the cause of any of these displays. In one instance, from the 16th of January 2012, it is alleged that a NATO plane created these circles of trails, though if this was true, the full purpose of the exercise that created them is not clear. An article in the Louth Leader, a UK local newspaper, claims that the aircraft was a NATO Sentry E3, a surveillance plane, which was on a sortie completing a standard UK orbit. As of writing this report, the photos shown here has disappeared from the site, though the story is still available. There has been little, if any, formal investigation into the phenomenon shown in these photographs, though a number of people have tried to raise questions formally using a Freedom of Information Act request and through lobbying politicians, such as through the Sky Guards group, which organised a meeting in the European Parliament in Brussels in April 2013, a meeting which I spoke at. In 2007, Rosalind Peterson gave an address to a UN climate change meeting in New York. Many hundreds or even thousands of YouTubers have uploaded videos of various kinds. Some are particularly strange and show planes trailing together, with examples in Germany and in the USA and in other places too. A number of independent good quality documentary films have been made by people such as Patrick Prazin, Clifford Carningham and Michael Murphy, and there are others of varying quality. Despite all these strange instances of significant trailing, no official answers are forthcoming, only flat denials. It is therefore left to those people who have observed these troubling anomalies to do their own investigation. This report is the result of one set of investigations. I'd just like to talk about some standard explanations for the phenomenon. A number of websites, including contrailscience.com and Wikipedia, claim that all trails that are ever seen are contrails. While these sites do contain some valuable scientific information, you will not find a full explanation for the phenomena shown in the photographs earlier in this video of the circles and grids. And these explanations would need, if they were to be valid, to include flight numbers and identification of the planes on the dates shown when these photographs were taken. Instead, this evidence is hand-waved away and assumed to be covered with a tagline such as "the science and pseudoscience of contrails and chemtrails." Another site, metabunk.org, also has some interesting observations and analyses, though it is somewhat selective about what it shows and analyses, as is the case with contrailscience.com. A number of people have talked about the spraying of barium and aluminium and other compounds, and it is said that they have found barium in rainwater. One claim that has been made several times is that there is a toxic level of barium in some rainwater. This claim has not really been proven to the point where it can be linked to chemtrails, however. An example case is that of Bill Nichols of Arkansas, USA, and this was reported on KLSA News in 2007. There is a good analysis on contrailscience.com regarding this case. Similar claims about aluminium levels have been made by Francis Mangles of California, USA, but what is not well known is that some soils can contain aluminium salts in clays and so on. However, the fact remains that barium titanate has indeed been proposed by the likes of Dr. David Keith, a climatologist from the University of Calgary, as a compound to be used in possible solar radiation management projects. The reason for persistent jet trails or chemtrails appearing has been considered by several people. Clifford Carningham has proposed the following possible reasons: to help create environmental or climate changes, to introduce biological materials to affect humans or agriculture, for military purposes, or to change the electromagnetic properties of the atmosphere, or to cause geophysical or global effects, to enable operation of exotic propulsion systems. At this point, it is clear the phenomenon is real, but it is not really clear if the trails are being created through the use of fuel additives or whether there are aircraft in operation that have a separate spraying system installed. Some people claim to have photographed additional nozzles on aircraft, but in some cases these have been shown to be for other purposes, such as science research projects. There are some examples on the Metabunk forum, such as the study of a story entitled "Exclusive Leaked Photos of a Chemtrail Dispersal System." Are these trails appearing as a result of external manipulation of our atmosphere? One possible explanation that I have proposed in the past is that at least some of the trails are appearing because the atmosphere has been manipulated by some unknown technology, perhaps similar or the same as what was almost certainly used around the time of 9/11/01 to steer Hurricane Erin. And this research is on Dr. Judy Wood's website. Perhaps also it is based on some of Wilhelm Reich's orgone technology, as others have proposed. I'd like to talk about the lack of genuine whistleblowers. Unfortunately, no genuine, knowledgeable whistleblowers seem to have come forward with detailed information that can be supported by comprehensive documents, photographs or videos. Though there has been some internet chatter about people like A.C. Griffiths and Kristen Megan, they do not seem to have brought forth any verifiable solid information. Though they may have made reference to documents such as owning the weather by 2025 and other documents that have been produced by the military, they don't seem to have explained many or even any of the observations that we have made. Chemtrails and jet trails in advertising and TV visuals. There does seem to be an unusual prevalence of jet trails in advertising and in places where you might not expect to see them shown. And one especially curious example of this was seen in a 2005 Virgin Trains commercial. In 2013, the BBC Wimbledon introductory visuals showed one or more trails in almost every shot where the sky was seen. Was it just innocent reuse of a stock image? This report represents the preliminary results of ongoing attempts to measure levels of air traffic over several locations during times of clear skies and during times when persistent trails or chemtrails appear. It is not meant to be an explanation for chemtrails, and indeed it is not meant to debunk anything or anybody. And it does not appear to prove there is a conspiracy to spray aerosol compounds in the sky, even though that it is possible that this is actually what is happening. It was simply an attempt to try and match or collect air traffic counts and log air traffic movements and then correlate this data with the appearance of trails. In this regard, at least, it has served a useful purpose. The whole project here or system relies on the fact that many aircraft are now transmitting ADS-B, which is Automatic Dependent Surveillance-Broadcast, messages when in flight. These messages contain the following information: a code number identifying the aircraft, sometimes called the ICAO or the registration number, a flight number, the altitude, the position, the speed and the heading. The tracker simply receives and decodes these messages, then software can be used to process the messages in any way desired. For example, you can count the number of aircraft which are detected in a given period with a certain range and above a certain altitude or between certain altitudes. Not all aircraft broadcast all the information. It seems that only an average of about 40% of aircraft detected broadcast their position, for example. So I'd now like to talk about detecting aircraft flying over your location and some of the earlier equipment and systems. This project essentially started in 2006 when I found out that it was possible to detect aircraft flying over a particular location, for example your own house. At that time I became aware of a piece of equipment called the SBS-1, which would decode ADS-B messages that it could receive from aircraft. It was then an obvious question to see if it could be used in some way to identify and or track aircraft that appeared to be leaving persistent trails or chemtrails. However, the cost of the equipment, £500, was an initial deterrent to taking this idea further at that time. In the last few years, websites such as flightradar24.com, FlightAware and planefinder.net have offered tracking and aircraft identification features, though they can in some cases be slow to update and somewhat cumbersome to use. Similarly, there are Android and iPhone apps which interface to these online services and allow you, for example, to identify flights by holding up your phone in the direction of a plane in the sky, and it will show the details of that plane on the screen. Of course, not everyone has an iPhone or an Android phone. As far as I am aware, the website and phone app solutions don't have logging features of any great sophistication, so are not much use other than for real-time viewing and tracking. So I'd like to talk about the AirNav radar box. In 2010 I decided to invest in an AirNav radar box, as I was still very curious as to what could be determined from using one of these to track aircraft. An important feature was that of logging any aircraft it detected. This meant that the unit could be left unattended and data could be examined retrospectively. However, there was still no easy way to get a visual record of trailing other than deciding to go out with a camera and photograph the sky during periods of trailing. This was not very practical, as time could not be devoted exclusively to a tracking project. The software that was shipped with the AirNav radar box provided a virtual air traffic controllers or ATC display. This was all quite natty, but its logging features were limited. For example, it could keep a list of all the aircraft it detected, and it could even play back a recording of logged data, but it was not able to produce charts or, for example, count the number of aircraft detected during a specified period, such as within a 30-minute period. Creating charts of the paths of aircraft detected. One of the original goals was to try and create charts which would show the path travelled by aircraft. This might allow the appearance of trails to be matched with the charted path of an aircraft to see how close the visual trail matched the logged charted path. This was done because the AirNav radar box could create a log file, and it was not initially clear how to create a chart from this, as the log file simply consisted of lines of text with various columns such as call sign, altitude, ground speed, track and aircraft ID. So what I did was I developed some Visual Basic for Applications routines in Microsoft Excel, and these were used to process the radar box files and generate charts of the path of aircraft, and also generate counts of aircraft detected in certain time periods. The data obtained from these log files was satisfactory, but it was time consuming to process and match up with the observations. The next step was to get some wireless webcams to photograph the sky. This was done at regular intervals automatically using a FOSCam webcam, or actually a pair of these for a period of time. These could be appropriately positioned on a windowsill, and this was done indoors because the weatherproof units were more expensive and more difficult to cable up for power requirements. Then a small program was developed which would switch on the aircraft logging in the AirNav box software, and also between dawn and dusk capture images of the sky from the two webcams and timestamp each one. All the data was saved on a netbook computer, and this had to be left running for 24 hours a day. Unfortunately, this netbook computer was used for other purposes for a few days at a time, which meant that the logging could not be run for more than a few days at a time. Also, the program was not 100% reliable, as the AirNav data logging could not always be successfully switched on, and this meant that it was not really possible to build a consistent set of data which could be used to count aircraft over an extended period of several weeks or months. The Raspberry Pi is a small credit card sized, fairly powerful computer which runs on a version of an operating system called Debian Linux, and it was released in 2012. I got one of these not long after the release, and I'd set it up as a low powered file server. It is a credit to the way that open source software systems work that allows developers to plug together software and hardware components and build both hobbyist and professional projects to a high level of sophistication in a relatively short period of time. In June 2013, I wondered if it was possible to connect the Raspberry Pi to the AirNav radar box, essentially to replace the netbook and allow the Pi to take the data from the AirNav box and save it, so that I did not have to tie up a netbook for this purpose. After finding a forum discussion about this, I also found another and potentially better way of doing a similar sort of thing, and the Pi Tracker project started to become a workable idea. I discovered ADSB message reception and decoding on Raspberry Pi could be done through the use of a program called Dump 1090, and it was possible to connect a USB dongle to the Raspberry Pi, and having compiled some software, the Pi was able to do most, if not all, of what the AirNav radar box would do for a fraction of the cost. A page by Dave Taylor provided a solid basis for some further Raspberry Pi development. By getting the right type of USB dongle, a digital terrestrial broadcast receiver, which was DVB-T, with the correct chipset, I could track the aircraft in real time using a Raspberry Pi, hence that all that was now needed was additional software to do the logging and counting. This was made much easier because the program which decoded the ADSB messages also presented data from these messages through a web page interface. And this code was written in C. In other words, all the hard work of decoding the ADSB messages was already done. I just needed to add some code to count the detected number of aircraft and generate the charts. It was relatively straightforward to adapt the dump 109 program code to make it count detected aircraft in a set period. It was also possible to get it to count aircraft in various categories, such as those above 25,000 feet, where trails are formed. All these counts were saved into a daily data file. Additionally, a log of all aircraft detected was generated and saved. The main software development was done using Ubuntu Linux installation with the help of CodeBlox IDE. The TV dongle and the dump 1090 code could also be used with a standard Linux installation. The C code was simply copied onto the Raspberry Pi and compiled so that it would run directly on the Raspberry Pi. The next thing was to photograph the sky, and in May 2013 a custom camera board was released for the Raspberry Pi, and this could be operated by software that ran on the Raspberry Pi. It was now therefore possible to have the Pi log and track the aircraft and photograph the sky unattended using less than 8 watts of power. Additionally, Raspberry Pi camera images were of considerably better quality than the webcams that I'd previously used, as the camera has a 5 megapixel sensor. Using the World Weather Online website, it was possible to obtain weather data at regular intervals to be saved with the air traffic data counts. Although ground level weather data is not especially useful in relation to conditions which may affect the formation of trails at 25,000 feet and above, that is, that weather in the stratosphere can often be totally different to the weather on the ground. The other thing that was needed in the Raspberry Pi was some configuration data. In order to generate meaningful data, it was necessary to add a configuration feature. Most importantly, the latitude and longitude that the Raspberry Pi was located at need to be set up. This would then allow measurements to be made based on its location. The dump 1090 software also contained features which allowed the software to generate a web page which would show the positions of detected aircraft on a Google map in real time. Additionally, the web page was modified to include the additional features such as aircraft counts and local weather data. In order to get a better sample of data, it was decided early on that several Pi trackers would be needed, and so several volunteers from around the country were asked to host them. I am grateful to the 5 volunteers who agreed to host trackers and help me set them up. Without their help, this project would not have been able to gather nearly as much data as it has. This meant that a method had to be developed for transferring the data captured by these trackers to a central location, which was actually my own Raspberry Pi, which was also used as a file server and a tracker. Hence, existing scripts were modified and a server was configured to accept and store the uploaded time-lapse video and aircraft data. Additionally, working with volunteers, the trackers were, when possible, set up to be remotely configurable. This meant that if certain problems developed in their operation or software needed to be modified or updated, this was possible, and it was even necessary on more than one occasion. The system uses an unmodified Raspberry Pi with an SD memory card like those used in digital cameras and similar devices. The memory card holds both the Raspberry Pi Linux operating system, called Raspbian OS, and it is used to store the data acquired from the aircraft as well as photos taken by the Raspberry Pi camera. Trackers were placed, when possible, on an upstairs windowsill which had a clear view of the sky. Once configured with a postcode, latitude and longitude, and station name, they were left running for 24 hours per day, 7 days per week. The tracker software included features to calculate local sunrise and sunset times, and would the tracker would only capture sky images and create plane charts during local daytime. Now, the Linux scripts and commands were created to zip up each day's data files and upload them to the server between midnight and 6 AM. After realising that the sky needed to be photographed approximately once every minute, it was also realised that several hundred photographs per day would be generated, and these would need to be reviewed to check for trails. Clicking through hundreds of photos per day would have been a slow process, so it was soon determined that the Raspberry Pi was capable of automatically generating time-lapse videos in MP4 format. This was done using another package that could be installed on the Raspberry Pi called libavtools. Time-lapse videos were generated and uploaded to the server every night. Charting parameters could be set so that planes within a certain range were drawn on the charts, and these were created every 30 minutes by default. Only planes above a certain altitude were logged on the chart, and these charts were saved in PNG format to the Raspberry Pi SD card. In order to generate some statistics from all the data files collected, a method was needed to collate all of the data. Originally, some tests were made just using collections of daily spreadsheets that had been generated by the trackers. However, this method was too cumbersome, and it was more difficult to, for example, average out sets of figures over weeks or months. Hence, after data had been successfully collected for several months, a Microsoft Access database was developed, and data from the CSV files from the trackers was manually imported into the database. As time-lapse videos were reviewed, another problem became apparent that in the UK, where all the trackers were situated initially, days where the sky was completely free of cloud for more than a few hours are rare. A whole day could be reviewed and there would be no usable sky images at all, as the weather was too cloudy to observe any trails. A method had to be devised therefore to measure how clear or how blue the sky was, which allowed a determination of how usable the image was. A software package called ImageMagick, which was used to add timestamp text to images and make a composite image with a plane chart and weather icon, was therefore used to analyse each sky image immediately after it was captured and to determine the blueness of that image. This was calculated as a number which ranged from about -85 to +250. Following some tests, it was demonstrated that in most cases the images that had blueness values of greater than about 50 could be used to look for trails. Over time, the Microsoft Access database was added to, and the next thing to do was to count the trails. Once the data was imported into the database, a query could be run to determine if there were any periods in each day when the sky was clear enough, based on the sky blueness factor, to look for trails. A Microsoft Access form was developed which allowed trail counts to be entered for the times that the sky was clear enough to see them, i.e. the query would filter out any days where there were no periods clear enough to see trails. This saved some time in reviewing the time-lapse video. The time-lapse video was reviewed in VLC Player, which has the ability to step through the video one frame at a time, and to do this you press the E key. This allowed closer examination of some video frames for some sections of each video. Now, I'd just like to talk a little bit about the data considerations that were made whilst I was putting this together. Even when the original AirNav radar box was being used, it was discovered that only a certain proportion of the aircraft seemed to be broadcasting their location data, and nearly all would broadcast their altitude and call sign. There was also an attempt to identify military flights, but this information came from the database which had originally come from the AirNav radar box, and none of these would broadcast their location, but it was at least possible to try and count them. The tracker software was designed to allow aircraft in certain altitude bands to be counted, and these counts were stored separately, and also the total counts of aircraft detected above the base altitude were stored. It was assumed that aircraft at or above 25,000 feet had the potential to form trails, and aircraft below this altitude should not form trails. Depending on where the tracker was sighted, it could detect aircraft over 100 miles away. For the purposes of this study, it was considered that an aircraft within 25 miles of the tracker could be seen if it was leaving some type of trail, when the data was analysed, this figure did not seem unreasonable. Most of the counts and figures were considered with regard to the assumption that for a trail to be viewed, an aircraft would have to be in range of the tracker, that's within 25 miles, and above the base altitude for forming a trail. A count was therefore kept of aircraft that fulfilled both these criteria. Taking into account the factors and assumptions in this section as a whole, the main objective was therefore to try and establish if the following average counts differed during periods of trailing and no trailing observed. So I wanted to check the count of planes detected, the count of planes located, that is those which had latitude and longitude being broadcast, the count of planes above the trail altitude, the count of planes which came into within 25 miles of the tracker's location, and the count of planes above the trail altitude and within 25 miles of the tracker's location. This also necessitated that the blueness factor was used to determine periods of clear skies so that a fair comparison of figures could be attempted. The Raspberry Pi camera has a 49-degree horizontal field of view and a 37-degree vertical field of view. This means that it can only capture about 1/8 of the horizontal field of view and about 1/5 of the vertical field of view. This therefore means that trails may have appeared on some days but not been picked up on any time-lapse videos. Conversely, it means that it is possible that on days when light trailing was seen, there may have been many more trails than indicated in the counts entered into the database. Now, it's generally assumed that the air traffic over the locations where the trackers were sighted followed a weekly cycle, and it was mainly civilian in nature. That is, the volume of air traffic on every Monday would be roughly the same, and the volume of air traffic on every Tuesday would be roughly the same. I'd also like to consider the counts of detected aircraft and those coming into range of the tracker. The trackers were kept in the same physical location during the time they were running. It was very important because if they were moved, say from an upstairs room to a downstairs room, an immediate effect on the ability of the trackers to detect aircraft could be observed. Also, with repeated observation, it could be seen that a tracker may detect an aircraft at a greater range in one direction, e.g. looking towards the southwest. This was likely to be the result of a clear line of sight view to the horizon in this direction. The signal from the aircraft is impeded by buildings, trees, etc. in between the tracker and the aircraft itself. However, this should be less of an issue for aircraft that came into range where trails were to be observed, because the signal would be stronger when the aircraft was nearer to the tracker. Daily count totals. It was necessary to develop an easy method to sum all the required counts from all the half-hourly periods from which the tracker had logged counts. And this had to be done with database queries. So when all the data was imported from the tracker, it ended up in one database table, part of which is shown here. And this allowed the data to be filtered, processed and averaged in a variety of ways using queries. Now, I'll freely admit that the way the results have been generated may not be the most appropriate or accurate. It is possible that using methods involving variance, standard deviations and other statistical analysis methods may have been more usual and more accurate. As it was, the general approach was simply to try and produce average figures for counts over a period of weeks and then compare these averages on days of trailing and no trailing. And anyone who's interested in generating their own results based on a different set of methods is welcome to contact me for a copy of the database or for something that can be exported into Microsoft Excel or something similar. Now, if you wish to read more about the development of the database, you can read the report on my website. I'd like to talk about the percentage located calculation. If it is true, as some people claimed, that chemtrails were the result of a clandestine spraying by the military or some other group, it was considered that the figure of the number of percentage of located aircraft might give some indication of this. The logic behind this consideration is that if clandestine flights would be less likely to broadcast their position in the ADSB messages. So during hours or days of trailing, the proportion of aircraft that were not broadcasting their position should increase. If clandestine planes are operating, broadcasting only their altitude or their ID, then the percentage located figures may decrease. But as can be seen if all the data is studied, the percentage located figure varied between about 30% and 50%, depending largely, it seemed, on the total number of aircraft detected rather than anything else. However, there could be a number of reasons for the variability in this figure. You'll see here that this is the amount of data which was collected from the trackers as of making this video, and data is still being collected too. So on my own tracker we had 228 days where I've collected data for this report. In Leeds I had 102 days, in Warrington 162 days, in near Bristol, near Cirencester 106 days, in Newcastle area 89 days, and in Isle of Wight area 45 days. Now we needed to generate queries which would calculate average daylight hourly counts for days when trails were seen and days when no trails were seen, and this was done using this blueness factor in each record for the periods of where the trailing was greater than 0. So then we had another query which would subtract the results of these two queries. In other words, it would subtract the averages on days of trails from the averages of days on no trails, and this would give us an average number of detected planes per hour, for example, a difference in those two counts for the days of trailing and no trailing. Now also in a similar way, this was done not just for hourly counts but for daily counts of the averages detected on trailing days and no trailing days, and so these two figures were subtracted. Now if you look at these actual figures and go through them, on first looks it appears that overall on a number of weekdays more flights are detected on days with trails, as we get negative figures when we subtract the trailing days figures from the non-trailing days. However, this picture is not consistent, but it does not seem completely random either. Now, it's not as simple as that, unfortunately, because as we see when we subtract the daily counts, we get roughly the same amount of traffic on days of trailing and no trailing. We could see that if we were to get together all the data from the trackers and see when we had trailing at more than one location that was visible, it became quite clear that we did see data. When we saw trailing on one tracker, it was more common, slightly more common, to see data on the other trackers. But of course I've only had 6 trackers running for a short period of time, and it's mainly been 3. Now, between the 28th of August 2013 and the 22nd of April 2014, trails were observed in one or more locations on 161 days, and from about 233 days across 6 locations. The table shows the dates where most numbers of trails were seen and totaled together from all 6 locations. The other thing I wanted to do was sort out the number of trails where we had maximum trailing and find out what the aircraft counts were on those days and compare those to the days when we had our high aircraft counts but no trails. So we see here, for example, the heaviest day of trailing occurred on the 25th of November in Warrington, and we had 91 trails observed, and we had 2,321 aircraft detected. And you can see all these other figures here, and for example we had the highest trailing in the Derby tracker, and where we had 4,308 aircraft detected on that day. And you can see all those figures there, and you can work through them in the report or pause the video here to watch them. So again, one of the main areas of interest was to try and find out if there was any correspondence between high numbers of aircraft being detected and or coming into visible range and high numbers of trail counts being detected. The total trails on a date query that was also sorted by location and detected aircraft count. And we could see, for example, that we can compare the air traffic counts on days of high trailing and days when we had no trails but high aircraft counts. And we still needed to make sure the sky was clear. So you can see here that on some days where we had no trails, we had higher numbers of detected aircraft. Indeed, for each of the locations, we did have days where there were no observed trails, but the numbers of aircraft were indeed higher. So this again means this is inconclusive. We don't know where this extra air traffic is coming from. Another goal of this project was to try and identify from time-lapse video and the charts which were generated which flights were creating trails. Now in 2010 I had done this on only 2 occasions using the AirNav radar box. In practice it was quite difficult to identify which flights were creating trails. And the table here that I've shown, I had 19 identification attempts on 2 days of heavy trailing, but I could only identify 5 of the flights which seemed to be making the trails, or potentially identify the flights. So here I'll match up some of the charts that I captured. For example, a trail in this video, the lower trail in this video frame, was EXS718N, almost certainly, which was identified from the chart and the direction the flight was shown to be going in. And this particular chart from the Warrington tracker was probably BAW3304 due to the curved direction that it was going in. This other example was almost certainly created by Virgin 6J, the flight there. The flights were determined from a combination of looking at where they appeared on the chart and what time they appeared on the chart and the direction they were flying in, so that that could be matched up on the video. Now I'd like to stop and consider the potential for these grids to form. For example, from the WA6 tracker, it is relatively easy to see the potential for grids to form from the paths of aircraft that are shown. However, this needs to be studied carefully, because if you look at the charts and compare these to the time-lapse video, we can actually see 2 grids form at approximately 7:53 AM and 14:36. Also, we can see planes travelling somewhere near a north-south direction at approximately the following times: 7:39, 7:43, 7:48, 7:57, 9:35, 10:20, which didn't leave a trail, 10:30, which didn't leave a trail, a persistent trail, and 11:09, which didn't leave a persistent trail. 11:34, 11:45, 11:59, 12:18, 14:12, 14:23, 14:36. Therefore, about 15 planes in all were travelling in a roughly north to south or similar direction. These flights seem to be travelling directly over the house, appearing fairly centrally in the video frame. Thus, it should have been easy to see these flights plotted on the charts generated for the appropriate 30-minute period. Studying the 19 charts generated on the 25th of November 2013, only 2 possible flights seemed to be travelling in the correct direction. And you would see that this flight had to be travelling through the central circle near the red cross, because that was essentially the field of view of the camera. Now at 11:09 there was probably flight SHT-7W, which had no persistent trail, and the other flight logged travelling in the north to south or northwest southeast over the tracker's location was at about 3:15 or 15:15 p.m. So we don't seem to be able to detect flights travelling in a north-south direction. Now, the other thing that came out of reviewing the time-lapse videos was some weather anomalies. For example, we have some video here from the Leeds tracker, which had the longest view to the horizon, and there's some quite strange cloud movements and formations which were seen. We've had, for example, here we have this thick cloud covering for most of the visible sky area with clear weather in the distance. But as you'll see, as the video progresses, this weather front suddenly comes forward at exactly noon and the weather clears to leave this cloud bank. And you see on the top level cloud, it seems to stay stationary for about an hour, and also the lower level cloud seems to stay stationary with only a slight movement to the east, whilst other weather seems to be in motion. So we have some stationary weather pattern in one area and moving weather pattern, which is what you'd expect in another. So what conclusions can we draw? From all the data gathered so far, it seems there is no large difference in ADS-B detectable aircraft on days of high trailing than there are on days of no trailing. The data here does not establish a clear link between levels of aircraft and levels of trailing. Looking at some figures in isolation, it could be argued that there is a lower amount of aircraft on days of trailing. The result, therefore, would tend to disprove a general statement that trailing is seen because of increased air traffic levels. If that is the case, then it is air traffic which is not detectable in the same way as regular air traffic. It was sometimes quite difficult to identify which flights left trails, perhaps because only a maximum of about 50% of the flights could have their latitude and longitude decoded. Without this information, it was impossible to know if the flight was precisely overhead or whether it was 100 miles away. The percentage located figure showed no appreciable variation between days of trailing and no trailing. The study from 25th of November of the WA6 tracker shows that it was not possible using ADS-B data to identify all of the flights which made the grids. Though looking at some of the charts, the potential for grids to form can be seen. These were not seen in the right place and not enough flights were detected to prove from this data that civilian air traffic is responsible for forming these grids. So the grids remain a mystery. Study of data from the DE-72 tracker also seemed to show that flights that were travelling in a north-south direction were rarely seen on charts, and if they were, it was over the far west of Derby, about 20 miles from where the tracker was sighted. Further attempts at identifying trailing flights could be undertaken even with the existing data. Days of trails or no trails. Now, no obvious reason could be observed why trails were seen on some days and not others. Again, taking the November 2013 time-lapse video, it can easily be seen that there are persistent and non-persistent trails appearing in the same periods of time and the same part of the sky. So this too remains unexplained. The tracker with the best view did seem to observe some kind of weather anomalies on some days. Why would cloud formations remain in the same place above the ground, whilst other weather drifts past? Why would this happen the same way with lower and higher altitude clouds? What is the cause of linear weather fronts? Further research. Now this could be done on the existing data from this project or by modifying the configuration or setup which has already been used and developed. Now ideas could include more study of the charts and time-lapse videos to try and match up flights and trails, especially when grids or similar patterns are seen. Additional Raspberry Pi cameras or IP-based cameras could be added for greater sky coverage, or a wider angle lens could be fitted to one of the cameras perhaps. Additional trackers could be located in other countries and tests repeated to see if the same sort of statistics are determined. Relocation of the antenna or aerial to place it with a clearer signal could be done to see if this improves the percentage of aircraft located. The trail logging and time-lapse video could be coordinated more with photography using high-powered zoom cameras such as the Canon SX50 or the Panasonic FZ72 or newer models. Another possible area that could be looked at is the use of satellite photographs for days of trailing and no trailing. So that concludes this video, and if you do want any more information about the tracker or any of the data or any of the thing that's been mentioned in this video, please contact me using the links below. Thank you very much for watching and listening.